Imagine a leaky bucket. Water pours in from the top, representing new customers, but there's a hole in the bottom. Water steadily drips out, symbolizing customers who decide to leave, also known as customer churn. In the cutthroat world of business, acquiring new customers is expensive. It's far more cost-effective to keep the ones you have. Predicting which customers are likely to churn allows businesses to take proactive steps, patching those leaks before they become a flood. Customer churn isn't just about lost revenue. It impacts the bottom line in multiple ways. There's the cost of replacing lost customers with new ones, which involves marketing and advertising expenses. High churn rates can also damage a brand's reputation, making it harder to attract new customers. A business armed with the ability to predict churn can allocate resources more effectively, targeting at-risk customers with incentives or personalized service to encourage them to stay. Enter machine learning, a powerful toolset for analyzing data and making predictions. Imagine a detective piecing together clues to solve a case. Machine learning algorithms sift through mountains of customer data, identifying patterns and relationships that might otherwise go unnoticed. These algorithms can learn from past customer behavior, transactions, and demographics to forecast which customers are most likely to churn. There's a whole arsenal of machine learning algorithms at our disposal, each with its strengths and weaknesses. Logistic regression, a simple yet powerful algorithm, estimates the probability of churn based on various factors. Decision trees, like a game of 20 questions, use a series of rules to classify customers as likely churners or not. Random forests combine multiple decision trees for greater accuracy. Neural networks, inspired by the human brain, excel at uncovering complex patterns in vast datasets. Support vector machines, or SVM, are like skilled swordsmen, drawing boundaries to separate churners from loyal customers. Imagine trying to bake a cake with spoiled ingredients. The result wouldn't be very appetizing. Similarly, machine learning algorithms need clean, well-prepared data to produce accurate predictions. This process, known as data pre-processing, is crucial for maximizing the effectiveness of our churn prediction models. Data pre-processing involves several key steps. First, we need to deal with missing values, which can be like gaps in a puzzle, hindering the algorithm's understanding. We can fill these gaps using techniques like imputation, replacing missing values with educated guesses based on other available data. Next, we tackle categorical variables like gender or service plan, which need to be converted into a numerical format that the algorithm can digest. One-hot encoding is a common technique for this transformation. Finally, we scale our numerical features to a similar range, preventing variables with larger values from disproportionately influencing the model. We've trained our machine learning model and it's churning out predictions, but how do we know if it's any good? Just like we wouldn't judge a book by its cover, we need robust evaluation metrics to assess the performance of our churn prediction model. Accuracy, while important, only tells part of the story. Precision and recall provide a more nuanced view. Imagine a detective rounding up suspects. Precision measures how many of those caught are actually guilty, while recall quantifies how many of the actual culprits were apprehended. In churn prediction, high precision means we're targeting the right customers with retention efforts, minimizing wasted resources. High recall ensures we're not missing potential churners, maximizing our chances of intervention. The F1 score provides a balanced assessment, considering both precision and recall. Cross-validation, a technique for splitting the data into multiple folds, helps us evaluate the model's performance on different subsets, ensuring its generalizability.